but I could go out and be amazing in color and I'm just shaking. Anywho, my name is Justin Herne. I'm a member of the St. Regis Mohawk tribe. I'm a graduate student at SUNY ESF under the advisement of Karin Limburg, right there. I'm here to talk about my master's research, which is exploring migration histories through biomarker chemistry for the highly migratory Cryptic Blueback Herne. I thought it was a pretty cool title. Karin really hit the ball on who and what blueback herring are, so I'm going to blow through it. They are one of 2 river herring species in New York waters. They are an Atlantic jet setter. Their range extends from Cape Breton, Nova Scotia, all the way down to St. Johns River in Florida. In their classic anadromous lifestyle, they spawn in freshwater areas. They emigrate out to the ocean, where they spend 3 to 5 years maturing, and then they return to their natal streams for their first spawning event. They are ecologically vital. They link ecological food webs, eating zooplankton, and then serving as prey to bluefish and striped bass. Along the coastwide, populations have been historically depleted, and that has triggered some recreational and commercial restrictions. The Hudson River, woo-woo, New York State's largest river within its state borders, extends 507 kilometers from Lake Clouds all the way down to the Battery in Manhattan. Its Mohican name, Mohicantuck, translates to where the waters were never still, which describes its semi-diurnal nature in the tidal portion of the estuary, which is Troy, New York area, all the way down to the Battery. Tom Lake, the Hudson River Almanac, has stated that there are at least 237 species in the river in its entirety, so it's a biodiversity hotspot. The Mohawk River is the Hudson River's largest tributary. Its Mohawk name describes its southwestern Adirondack origin near Boonville, New York, that traverses through the Mohawk Valley and empties into the Hudson River near Troy, New York. It represents 25% of the river basin drainage area. It also has a 27 to 25 meter impassable barrier near Troy, New York, called Cohoes Falls, creating an almost impassable barrier except for the American eel. 19th century Erie Canal was built, linking Buffalo to Albany and essentially to New York City. It was a system of utilizing parts of the Mohawk River and engineered canal portions with dams and locks to get around the Waterford, to get around Cohoes Falls. The Waterford flight of locks was built, which was 7 locks that created a seamless passageway from the Hudson River into the Mohawk River, connecting them. Accounts of the blueback herring in the Mohawk River happened nearly a century later, with more recent research identifying variations in their textbook lifestyle. New York State DEC has expressed interest in understanding why the Mohawk River, are they significant, what the significance is, which has led me to my thesis. I have a lot of stuff going on in my thesis, but today I only have probably 10 more minutes, so I'm going to focus on objective 1. I want to find out where are they spawned and how we can track them. Essentially, I want to figure out if they're Hudson or Mohawk fish, and I also want to identify if we can utilize different provenance tracers to figure out if their location is correct or incorrect, or to get a little bit clearer of a picture. Samples were taken above, at, and below the confluence of the 2 rivers by Scott Wells, over here, Region 4, Stanford Fisheries Unit. Adults were sampled. After biological data was taken, I extracted otoliths and eye lenses. They were cleaned, embedded in epoxy. They were polished. It was a really tricky process. I cracked about 7 of them, and Karin was not too happy. But after they were polished and prepared, I then analyzed them in-house at SUNY ESF's Analytical and Technical Services under the advisement of Deb Driscoll. I utilized laser ablation inductively coupled plasma mass spectrometry. Essentially, a big laser blows through my samples, plasma vaporizes it, and the mass spectrometry quantifies the different signatures. I utilized different analytes from otoliths and eye lenses. There were 24 total, so it was a lot. I thought one really cool photo was this eye lens. You can see all the different encapsulated protein layers, and you can see these spindle fibers in the middle. Basically told me that I didn't polish too much, so I did it right, finally. Before I did any data analyses, I wanted to figure out what the provenance was. Karin suggested earlier that we can utilize strontium and barium ratios in the otolith to identify whether or not it's a Hudson or Mohawk. The strontium correlates to the geologic bedrock. Essentially, the Mohawk River is strontium enriched. The Hudson River is strontium depleted. So when we look at otoliths, we can see for Hudson individuals, relatively depleted. We had a boundary of 1.0 to 1.5. in one of the ratio bounds, which was relative, and then in the Mohawk River, it's relatively elevated. We can see the Hudson River is flat and boring. The Mohawk River is kind of like a corona or convex. As Karin previously stated, we can see the entrance into the freshwater Hudson reaches with this distinct drop in strontium to calcium, and then for both of them, we can also track their immigration out to sea by the increase in strontium, which was relatively above 3.0. Barium was utilized to validate whether or not they were freshwater or they were in the marine mean. We did have individuals that really didn't follow a pattern. It was very confusing. They really didn't know what I did wrong. However, after careful consultation, we decided that they potentially represent estuarine spawn blueback herring, so individuals that respond in the more brackish below the salt front. An atypical spawning strategy, but not impossible. These individuals represented higher strontium signatures. They did not represent any drop into the freshwater Hudson, but they also did tell us that they went out to sea by their barium and their strontium. Out of 148 fish that we sampled, we analyzed 67. There were 38 Mohawk River, 23 Hudson River, and 8 that were in the estuary. So, great. My first part of my analysis, I wanted to identify whether or not there were differences in the analytes by site location. So we had 3 locations, we had 24 analytes. Let's see what's different from place to place. Utilizing different ANOVA approaches, the only analyte to have a parametric distribution was strontium. However, it had unequal variances, so we utilized a Welch's ANOVA for our statistical test. The others were non-parametric, therefore we utilized a Kurzweil-Wallace test. Out of the 24, 9 indicated differences in at least one location of provenance. They were all statistically different. From the 9, we identified that 6 of those locations had multiple differences that were all statistically significant. The ones that really stood out, other than strontium and barium, were phosphorus, rubidium, and then lens lithium, and the major isotope of mercury. However, utilizing the ANOVA approach doesn't give you any type of dimensionality with identifying whether or not there's an interaction of elements if one influences another. So, the results from here, we then went to perform our principal component analysis. Essentially, this test is going to tell us what can explain the majority of the variance in my data and what can also serve as something that's very influential. We utilized all 24 analytes just to make sure we weren't missing anything, or if an interaction was occurring, we could capture that. Basically, the main things to take away on this loading matrix, everything was standardized from 0 to 1. The largest things, 0.5 to above, had more significant ability to talk or to explain the variance in the data. Things that were smaller, obviously, were not higher, didn't have as much explanatory power. We also had individuals that were negative that basically told us that if they negatively influenced or if they negatively worked against being able to talk or explain the variance. Main takeaways, principal component 1 was heavily influenced by metallic islands, analytes. Principal component 2 was heavily influenced by metallic otolith analytes. And then principal component 3 was just the isotopes of mercury and sulfur. From there, we then performed a discriminant function analysis. This is my last of the analyses, so don't worry. We wanted to basically quantify if there was a model that could essentially try to piece the analyte data into my predefined provenance groups and come up with the best linear correlation and possibilities to make that happen. The main takeaways in my canonical plot, we have our 3 different provenance groups. We have our 50% and 95% ellipses. We also have all of our specimens projected onto the Cartesian plane that correlate to their provenance location. We also have vectors in the middle. The longer the vector, basically the more influential in discriminating provenance, and also the more influential in essentially impacting those provenance locations. We were able to determine that we were statistically different and statistically strong at identifying provenance locations, and that there was great distinction. When looking at our standardized scoring coefficients, basically all the coefficients were put on the same standard scale. Larger numbers, obviously more influence and more ability, and then ones that either had negative or lower numbers were either negatively influencing provenance distinction or also minimally influencing. Other than strontium and barium, because we utilized those as provenance tracers, we were able to determine that lens magnesium, lens manganese, lens rubidium, the 198 isotope of mercury and also otolith phosphorus were giving a lot of influence and able to influence our provenance distinction and potentially utilized as additional provenance tracers. Out of 64 fish that were analyzed and in this study, only 2 were misclassified, so that's pretty good. I did something right, that's exciting. That's only 3% of the individuals, that's great. The entropy R-squared essentially is a scale of 0 to 1 that rates how well the model was able to essentially put your individuals based on their analyte data into your predefined categories. 0.8, that's great, close to 1, woo-woo, did a good job. The -2 log likelihood, essentially, it is a statistic that shows you what the model fit is. The lower the number, the better the model fit. Before I did my principal component analysis, I utilized all the otoliths and islands analytes, and it was like 491, so not very good. So this was the best model I've had with a very low number, that's great. Over to the confusion matrix, this essentially identifies who was correctly classified and who was misclassified. From top left to bottom right on the diagonal, we know that 7 individuals were properly estuary, all the Hudson rivers were properly classified, and then the Mohawk River 33 were properly classified. The 2 individuals that were misclassified were specimen I-10 and then specimen M6. I-10 was originally classified as Mohawk River, but it's actually estuary based on the analyte data, and then M6 was actually estuary, but I originally had it as a Mohawk River, so, oh well. I'll try next time. However, these strontium and barium signature profiles, they were really tricky to tell. There's really not a lot that I could tell that could point me either estuary or Mohawk River. This also supports the need for having multiple analytes in elucidating provenance. So, yeah, I was able to identify provenance. That's great. Also, it was exciting to see potentially estuary and main stem spawning individuals. Like I said, atypical but not impossible. Blueback herring have a wider range of salinity tolerance. They're also less picky at spawning site. There could have been intra or interspecies competition for spawning habitat. This could also reflect some energetics. It's very taxing to school all the way up to the Hudson River, especially to the dams, so maybe it's a trade-off where they're able to spawn in the estuarine reaches, so this could be like West Harbor straw, lower, closer to the ocean. So they're able to expend more energy on, reproduction and also potentially foraging after the fact. They're really tired. Also, we were able to identify several additional analytes that in this study really helped to make provenance very clear. So lens, manganese, rubidium, the isotope of mercury, which we probably won't use because it's not very abundant. Magnesium, and then otolith phosphorus. That's really exciting. This can also help create a more detailed photo in where provenance is. This could also maybe correlate to different habitats or different areas in the Hudson River if we're able to identify manganese in certain spots. Future analysis, I'm hoping to finish the rest of my thesis in part 2, so that's great. And then I would also love to analyze the rest of these fish, and if I could repeat this study, have more samples taken from the lower estuarine portions to get a representation or approach at quantifying those individuals. Another exciting part is that this is one of the first studies to analyze blueback herring and otolith lenses, if not the first, so that's cool. Also, there isn't really a lot of information out there talking about analyzing estuarine-spawned blueback herring. So I think this also helps add to our overall understanding of the species. That's it. Thank you for everyone that helped me. I'll take a question. All 5. Mandy.
So is it common knowledge that eggs can tolerate salt water, like estuarine water, or do they have to be fresh water? Like, obviously that fish.
Well, I did experiments on shad larvae and eggs, and they were pretty tolerant.
Okay.
Yeah, I mean, they can handle 10 parts per thousand. So I think so. I also wanted to interject that one of the things I didn't talk about was the fact that we also figured out that they were batch spawners, which means that they ripen up batches of eggs and dump them, and it's been observed by Bob Schmidt and Tom Lake that they've been spawning down in the estuary. So it's not a big surprise when you actually find the cost of it. And Kara Yule-Hodgkin saw this too with her data, but couldn't figure it out. And we finally just bit the bullet and said, this has to be estuary. It's not super common, but it's there.
What she said.
Just like Karin said, I've seen reports or research that has essentially stated that the eggs are relatively viable and it's not something that's like a total TKO. So it's great. Anyone else have a question for me? Anyone? No. Thank you so much. You know,
When you like it, now you're right.
all right.
I'm still along with it.
I know, I didn't tell you. I'm so sorry.
You gotta get it out.
I think it takes the wheel.
I think it would be interesting.
Oh, it's cheap right now. I'm tired of getting it.
And what I figured out was that you were so yeah, I started